And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. Lots of stuff going on, including whether or not there's weather, warnings, alerts, watches, advisories, cosmic rays, and indeed earthquakes. Lots of things going on, including something they called Gina Maria Colvin Hill about. At 1919, in 304 angstroms, there was a scary, spooky spaceship, which you can see right here, which means the end is near, the veil is lifting, and we're all going to die tomorrow. Or perhaps in 5 minutes. Who knows? Who knows? It's a spaceship, which only appears in ionized helium spectra emissions for some reason. But in any case, it's clearly a spaceship. Again, call Mr. MBB333 and Gina Maria Colvin Hill and every other hack fraud out there who is very scared and spooked about that. Most of the activity going on in the sun right now is in the southern hemisphere, and we still actually do have some chance of additional coronal mass ejections here, as we've seen quite a lot in the past 4 days. So there's just 1 day of solar activity, and we see some filaments in the southeast, a sprite over there as well. I think that one might even be bigger. Yeah, check it out. That's a good one there. That one happening at 2328. And I believe that is only showing up in 304 angstroms. Now, we've put up a video here of the LASCO C3, just to show you the back until 4 days ago. So we're including 4 days of data there on the LASCO C3. This is located at Lagrange point 1. For all you new viewers who are not aware where the SOHO spacecraft is located, about 1 million miles closer to the sun than is the Earth. And you see a bunch of coronal mass ejections there, all appearing to miss, almost entirely appearing to miss the Earth-facing zone to the east. Also, a sun-diving comet is visible in that video. Let's zoom in a little bit. Just enough to show the time and date stamps. So lots of stuff happening despite very low numbers of sunspots, very low levels of solar activity, low levels of radio flux. And again, that is located at Lagrange point 1, in between Earth and Sun. Let's get a look at what's going on at Lagrange point 5, down at stereo A. And this is just going back 2 days now. And you can see some coronal mass ejections in the Earth-facing vicinity. Earth would be out in this direction from the perspective of Lagrange point 5. And I'll put that diagram back up again. There's the location of Lagrange point 5. Keep in mind that's not to scale, folks. So some more coronal mass ejections in the Earth-facing vicinity, but not expected to strike the Earth. The radio flux at 74 solar flux units. There's the 1-year chart on the 10.7 centimeter, or 2,800 megahertz radio flux, which is the radio emissions from the outer solar corona, which is why we made that GIF animation. And that is a very proportional number to sunspot number. It's why we cover it, especially around times of solar minimum, when there are 0 sunspots like there are now. So right now you've got the radio flux just under this 75 line. You've got the sunspot number all the way down here at 0. And here's a composite image, as we do see a small area of magnetic organization in the southeast. It's not a sunspot, last I checked. We'll let you know by the end of the video. This is a composite including 171 angstroms. One of the wavelengths of ionized iron. Also, the colorized magnetogram shows up on those images. And we've got some great helio viewers. First, let's take a quick look at the fields. Make sure that's the newest image. And there are the fields. Doesn't look like it's changed much to me or become a sunspot since I did show prep. We'll show you by the end of the video a high-res image. Here's the sun at 94 angstroms. And we'll save the rest of our Helio viewer movies till the end of the video. We'll do a small cosmology segment and talk smash lights and so on after this message from our sponsor, which is me. So I'm Dan, aka smAsho, if you weren't aware, and we make these videos at massive personal risk and expense. One of the playlists you'll find at YouTube is the Smash Lights segment. It's all part of the Smash News Network. Yesterday we premiered a new series, a special report, Smash Hole of the Week. So go check that one out if you haven't done so yet. Yes, a new segment, the Smash Hole of the Week, and we would invite our viewers to not be COVIDiots. And of course there are various definitions for the term COVIDiots. We won't get into it today. We are streaming live to Twitch, by the way, when we made this video. And we don't always stream live to Twitch, but we regularly do the Daily Space Weather videos this way because Twitch is such a good streaming platform. Also, we haven't been purged yet from Twitter, so feel free to follow us over there. We've just retweeted a swamp creature tweet from John Brennan, one of the more putrid politicians, swamp creatures of government. And I won't tell you what the tweet says because it's from John Brennan. And let's just say I had a comment that was less than complimentary. In any case, I would recommend everybody get back on topic and start referring to the fact that Dr. Fauci is a fraud. Thanks to all of our YouTube subscribers. Please tell your friends and foes, science noobs and science pros, about the channel. Perhaps you can help them define the term fraud, which is an intentional misrepresentation of material facts. Were you aware? We also put up a BitChute exclusive yesterday. Here's a clip. It's our 300 subscribers special. Less than a year ago. So those are the kind of arguments you'll get in with if you start arguing with people on Facebook. So perhaps check that out. It's entitled 300 Subscribers Snark Fest at 8 = capital D, do the math, big tech /BitChute exclusive, bitchute.com/smashamash. Thanks to our subs over there. And we'll do a cosmology segment today. And what will it be about? Well, we're going to roll dice and figure it out randomly. It's a 1,031-sided die, but before we do that, thanks to our patrons, the true source of funding for the content, it's patreon.com/smashamash. If you'd like to get involved on the ground level, we've barely gotten started creating content here at smashamash.com, smashamash.org. Again, if you'd like to help us out, it helps a lot. It's the true source of funding for the videos, patreon.com/smashamash. Thanks again to our patrons. Today's random number between 1 and 1,031 is 167. Let's see what we've got at 167 on the Neil Gorell Swift Bat X-ray Observatory. And this one is Large Magellanic Cloud Object X2. So this is a cool one. An X-ray binary in the satellite galaxy Large Magellanic Cloud. Now, once you start delving into this stuff, you'll be able to just know what you're looking at here. LMC stands for Large Magellanic Cloud. There are the historic X-ray outputs of X2. The X-ray binary system located in that satellite galaxy. And you can see we've got data going back to 2005 at least. And it's a pretty consistent X-ray source there. You can see pretty stable in terms of its output. Let's take a look at it on Simbad. So here we'll have an object that's nowhere near the galactic plane. And if you zoom out, you'll see that it's, again, in the Large Magellanic Cloud. If I can zoom out enough. I'm not sure if that will load on that setting or not. Yeah, there we go. And And we seem to have had an increase in warp engine output here. Please bear with me a minute. I got to check on the life of the stream, as we don't want to have to come out of warp in order to continue on with the video. There we go. I think we've got everything calibrated now. Yeah, so Large Magellanic Cloud, and there is the cloud, and the spot of X2, LMC X2. Pretty easy to remember there. And we'll actually go onto the Aladdin light and take a look at it there. I have a feeling it probably shows up in Chandra, which is one of the X-ray telescopes. But it's not there. How about on the 2MASS? Nope. And it's looking pretty dark. How about the Fermi? No gamma ray emissions from it. And how about XMM Newton? Nope. The Spitzer? Showing a heap and helping to nothing on the Spitzer. So it's a bunch of X-rays coming out of a pretty dark point in space there, folks. And perhaps you can go have a read about that LMC X2. I'm sure there's all kinds of articles about that. Number 167, a low-mass X-ray binary located in the Large Magellanic Cloud. So that's part of today's cosmology segment. In the rest, we'll talk about cosmic rays. And for our regular viewers, you're probably well aware that cosmic rays are kind of important to things like the Earth's climate. And I've been trying to murder my phone here by running the flashlight unnecessarily for like an hour. Let's get that shut off before I destroy my LED. So, cosmic rays are kind of important, as they seem to be associated with all kinds of cyclical behavior of things like the Earth's climate. Cosmic rays make for colder days and warmer nights, as they cause low clouds to nucleate. They create ionization pathways in the atmosphere. And, well, it's just one of the many reasons why all your weather comes from space. Let's take a look at some cosmic ray monitors, such as Apatity and Barentsburg. Now, at Apatity, you can see over the past 30 days, it's utterly flat, as we're back to the exact same spot that we were 30 days ago. At Barentsburg, it's pretty similar there. Almost the exact same spot as 30 days ago at Barentsburg. Next, we'll look at Athens, Greece. Going much farther south. And there is the 30-day chart of Athens. Looks like a bit of an upward trend there, right around New Year. And then a ramp down. So interesting there. Perhaps it gives us insights into the interior of the Earth here. The way we're seeing utterly different cosmic ray charts at Athens versus Barentsburg and Apatity. Next, we'll go even farther south to Mexico City. Athens probably has a pretty similar latitude to here in Pennsylvania. Mexico City quite farther south. In a subtropical zone, basically. Or is it full tropical? I think it's subtropical. In any case, pretty flat there over the past 30 at Mexico City. Quite flat there, yes. And next we'll look at Oulu, Finland, and DOMC Antarctica. Going much farther south. But first, Oulu, and you can see a small uptick at Oulu over the past 30 days. A very small one. And here's DOMC Antarctica. Flat over the past 30 days. And that's one of the closest cosmic ray monitors to the geographic South Pole. And that's today's cosmology segment. We don't want to put too much cosmology stuff in the daily space weather videos, as we don't want these to be too long. Let's move on to more daily space weather data. We've seen an uptick occurring, as I did show prep here, as the solar wind density came up to about 12 protons per cubic centimeter. Also, a shift in the phi angle at the same time. Looks like an indication that a coronal hole wind stream is arriving. expect to see this drop off and this to come up at the same time. An increase in the solar wind speed and a decrease in the solar wind density is the characteristic fingerprint of coronal hole wind streams. It looks like perhaps the density has already leveled out. And we've seen pretty weak coronal holes here, so we don't expect anything too fireworks-like from the coronal hole wind streams. Current solar wind speed, only at 314 kilometers a second. I would expect to see this come up to about 400 kilometers per second when you see that solar wind density drop. Next, looking at the KP index, which has been at 1 for the past 9 hours. Geospace Magnetosphere movie, it's 4 hours of data, courtesy University of Michigan. The space weather modeling framework giving us a visualization of what's going on in terms of magnetohydrodynamic pressure. And you can see that slight uptick in the solar wind density there shown as pressure on the bow shock region toward the left. Next, looking at ground magnetic perturbations. We look at it daily since we're living through a polar excursion. Welcome to the Neo-Renaissance. Welcome to the polar excursion, folks, where the South Geomagnetic Pole is nowhere near the geographic South Pole, somewhere south of Australia, off of the Antarctic continent entirely. We've got 2 North Poles, one over Canada and one over Siberia. That's 4 hours of data on that. And I've brought up the 7-day chart here of the proton flux to show you that none of those coronal mass ejections have led to any increases in the proton flux as measured at the GOES 16, which is located at about 300 kilometers altitude at the F ionosphere layer. Here is 3-day chart on the X-ray flux. Here's a 7-day chart in the X-ray flux. And you can see some very minor flaring only, nothing even getting into a B-class range, but lots of coronal mass ejections, so you can see coronal mass ejections with no X-ray flares, and indeed no sunspots, as a large portion of that included no sunspots. Here are the higher highs and higher lows we forecasted yesterday on the GOES magnetometer. And yeah, that's a 3-day chart of that. And let's see what's going on the current sheet. Here is the current state of the current sheet, the heliospheric one, the one that actually affects Earth geomagnetism. And keep in mind at the date that the data here is about 2 hours and 14 minutes old. And once again, as forecasted yesterday, we are in the South Pole-oriented current sheet, as shown there in red. There's the last frame. Again, keep in mind the data is 2 hours and 14 minutes old and can suddenly change with no warning. And we're expecting some similar readings on the GOES magnetometer as a result of seeing that. Here's a line-of-sight coronal hole plot. Nothing exciting to comment on there. No major coronal holes. Small one associated with the southern solar polar field shown in red. And here's another view of basically the same data. This shows you, like the last one, the Earth B field in blue. It also shows you the poloidal fields and a solar magnetogram. Last but not least, when it comes to solar magnetism, we'll look at the magnetic field plot of the corona itself, the sun's atmosphere, a turbulent place. And again, not very exciting. Not a lot of features, including not a lot of coronal holes. And let me just check the life of the stream here once again. And again, thanks everybody who views, whether you view live or Memorex. We greatly appreciate your comments. So leave us one. If you're up before dawn, you may see the moon and Venus rising before the sun. I like to face my star chart to the south, as I'm currently facing the south, and so is my couch. Also, the ecliptic is in that direction. Yes, I like to stare at the sun. Oh, yes, that's right. And here's what's going on in the solar system. You can see Frito-Lay is maintaining a stranglehold on the gas giants. So we've got people not understanding the distinction between coronal holes and their anus. We've got a triangle forming here in the shape of a Dorito in between the Jupiter-Saturn setup, the Earth, and Uranus, indicating that Trump brand tortillas are likely to overtake Frito-Lay. So don't be surprised to see Trump brand tortillas He'll be offering them in full organic, non-GMO, as just like Frito-Lay, because you got to compete, okay? So that it's becoming obvious why the Space Force is a thing. Apparently they're going to be shipping tortilla products to the Galactic Federation. There's where we expect things to be in a week, as Mercury's swinging around to take another pass. As we get lapped by Mercury. Let's talk electrons. We don't see charging hazards. Here's a one-year chart of the electron flux. That's Solon.info, by the way. Solon.info/solar to find all that data. And here's the electron flux forecast model. And I would tend to agree with that, as it looks like there's a coronal hole wind stream arriving, expecting slightly lower levels of electron flux here during a coronal hole wind stream. That's what we would expect to see, as coronal hole wind streams are primarily composed of hydrogen nuclei, otherwise known as protons. And those protons really want an electron. They will steal your electron, create ionization pathways, and indeed create Bremsstrahlung, or breaking radiation, as a result of all of that chemical reactivity. So here's a chart of the atmosphere, showing you the ionosphere there on the right, and that F layer, that's where the GOES 16 makes its measurements. We show this daily to help people understand where things are. And here's a visualization through the inner Van Allen belt to about 12,500 miles, where your GPS satellite is likely to be located. We hope it's located there. And this will show you GPS errors. I'll let it play through a second time here, as we've got some more data sets that we don't always show today. What happened to Pakistan's power grid? By the way, Pakistan's power grid did not seem to be taken down by jihadis or any sort of partisans this time. The question is, what did cause it to go down? Here's another diagram. This one shows you distances in miles. And again, you can see GPS satellites there are at about 12,500 miles in their geosynchronous orbit. So again, we haven't seen any proton strikes. We don't see anything happening with 1 decibel absorption in the ionosphere. We do see some fluctuations in the U.S. power grid, but nothing like when you see a geomagnetic storm. I just brought this up because this is one of the many links at the bottom of pages like the Space Weather Modeling Framework, Geospace Magnetosphere movies. You can find this down at the bottom. This is called the Geoelectric Field 1-minute empirical 3D map. And we see a bit of induction along the eastern seaboard there. What's up with that? And we see some outages in New York. Those were not there when I did show prep, showing 17,000 custies out of power. Let's look at the ionosphere layer. Going back up into space again to about 300 kilometers. We see some anomalies here, once again in the southern hemisphere. Southern Atlantic Ocean, Central Pacific, and a little bit in the southern Indian Ocean as well. A bit of an anomalous ionosphere. So there's the latest image. It's from 12 o'clock Universal Time. And you can see a little bit heavily charged up there in the southern hemisphere, although not as much as previous days. We've seen an uptick in earthquakes also. We'll cover it in a minute. First, volcanoes. Abico's been erupting. It's producing an 11,000-foot plume of ash. Sakurajima now on the list once again, as it explodes and produces a 7,000-foot plume of ash. Suwanosejima exploded as well. Unknown volcanic ash cloud. Please don't attempt to hang glide the caldera. Cinnabung also erupting. Unknown volcanic ash cloud there. Please don't attempt to triple Lindy or back handspring over that caldera. Dacono's exploding. It's a flight level 070, 7,000-foot ash plume. Don't even fly your drone over that, as we'd like to see your drone footage. Popocatépetl exploding, 20,000-foot ash plume. Sangay exploding, 20,000-foot ash plume. Revenador and Peru, both exploding, producing a 14,000 and a 27,000-foot ash plume, respectively. That's Sabancaya. Yowzers. Please do not attempt to pole vault the caldera. We've had 2 6+ magnitude quakes here, one in South America and one in Oceania. We'll get to it. Excuse me. Also some additional quakes under Hawaii. Let's take a look at that one. It's the first on the list. It's only a 2.5 magnitude. Was it under Mauna Loa? And indeed it was under the northwestern flank of Mauna Loa. So we see some deep quakes here, such as this Indonesian and this Chilean quake. And both of those large quakes were 6.1s, I think. Here's a deep quake in the Fiji Islands at over 500 kilometers. Another quake strikes Croatia, an aftershock. There's a deep quake at Fiji over 566 kilometers. And there's one coming in while we do the video. We'll get to it. Another deep quake at Fiji. A 4.7 strikes Taiwan, followed only 4 minutes later by a 4.5 at depth at Chile. And there you go. The largest quake of the past 24 tied. There are 2 large quakes there that happened. Let's see. About 3 hours apart. One in Chile and one in Vanuatu, and both at depth. So 2 6.1 magnitude quakes. The Chilean one at 217 kilometers. The Vanuatu quake at 160 kilometers. And let's see what came in while we did the show. A 5.0 at Papua New Guinea struck at 51 kilometers depth while we stream live. And again, it's twitch.tv/smAsho. Perhaps check out the free mobile app. It's quite good. It'll send you advisories when we go live. And we don't make all of our live videos there. We also have YouTube and BitChute exclusives, although BitChute does not allow live streaming yet. Fingers crossed for that. We will use it regularly if it's good. Next, you're looking at the jet streams here of the eastern world. We've got a pretty concentrated jet stream there over the western Pacific. Quite a high-speed section there at 215 miles per hour. As well as extreme bends. Check it out. We have the jet stream blowing backwards here over the western Pacific and indeed the Indian Ocean. East to west jet stream flow. Ask a pilot. That's not the normal way things work. Here is the western world's jet stream situation. And we see extreme meridional jet stream bends here over North America, blowing north to south, south to north. This split over the North Atlantic, which we've seen several times, actually, in the past couple of weeks. So all over the place, a very chaotic jet stream situation there, especially over northern Europe. And let's take a look at the 10 hectopascal winds for once. And there you can see this double rotation here in the 10 hectopascal winds. Here's the southern hemisphere, a more organized rotation there. And again, there's the jet stream scenario for the northern hemisphere. And we see a little bit of lightning in Texas. Leave us a comment if you had lightning in Texas. Did you have thunder snow? Let's check lightningmaps.org for the real-time lightning map. And are we seeing current lightning here south of San Antonio? Looks pretty calm at lightningmaps.org. Next time you hear thunder, check it out. And we see some near Casablanca. Also El Jadida. Hey, El Jadida. There's thunder rolling in. Next, looking at the U.S. Doppler radar map, I think. Oh, I've got bad audio. There we go. Problem solved. Sorry for the bad audio, folks. I forgot to mute one of the mics. Here's a U.S. Doppler radar map. Heavy snow falling in Texas. And it looks like it's stagnating. And I want to just briefly talk about the Earth's rotation once again. Now, the Earth's rotation, as well as the moon's action, creates an equatorial bulge, where the water, and there's a lot of water at the equator, causes the Earth to bulge out. If that equatorial bulge shrinks because of things like the oceans getting cooler, or less water being in the oceans, and more water appearing at the poles as ice, the Earth's rotation speeds up. That's just the way it works, folks, like a ballerina pulling in her arms, or perhaps a figure skater pulling in her arms while she spins. The Earth spins faster. And so I can't believe people aren't citing the fact that 2020 had the most fast days. In other words, the Earth's rotation sped up more than it has in like 50 years. And I don't know why nobody is calling this out, because this is a sign of global cooling, folks. Cool water takes up less space than warm water. So there's all kinds of articles that you can go find about how, oh my God, Earth's rotation is slowing, except Earth's rotation hasn't been slowing. It's been speeding up all throughout the year 2020. Even the planet wanted to get out of the year 2020. Let's look at a snow forecast for places like, Texas. So yeah, it's an indication that water is either leaving the oceans or water is getting cooler in the oceans. Here's the Euro forecast for snow in Texas. It's snowing in Texas. Snowing and it's really, really crazy. Snowing in Texas. Do you really feel like seeing 10 inches of... Oh, okay, it's not that much. 4.3 inches, 3.7 inches. That's the European forecast through 2 p.m. Eastern Time tomorrow. So that's 1 p.m. Central Time. Looks like some additional snow expected to fall all the way into Louisiana, Mississippi, even some in Alabama. It's a pretty significant snowfall for places like central Louisiana. Oh my God, the Earth is so hot that the rotation is speeding up. It's so hot that we've seen 3 years in a row with 2 standard deviations above normal snow. Yeah, it's true, folks, it's true. Now, we don't see any standard deviations above normal snow for this year. We see us exactly on the 30-year average for snow mass balance. Although snow extent has been pretty much all over the place here. So there's the snow extent tracker. And you can see the snow extent did indeed get 2 standard deviations above normal back in late October. So we saw early extreme snowfall. But now we're more around the average. In fact, we actually got to pretty low levels of snow extent there. And we've been seeing late springs in the northern hemisphere as well. And I don't know why we're missing so much data there, but you can see the current snow mass there is exactly on the 30-year average, 1982 through 2012. Here's what's going on in the cloud layer. As it's getting light here, but it's still too dark to get a good view. So we're using the NASA GOES shortwave radiation map. And thanks for letting us know, Kathy Garden, about the horrendous audio. That's what I get for screwing around with the audio before the video. Yes, public opinion, it's like turning a battleship, or indeed an aircraft carrier. So that's what's going on in the cloud layer. Here's what's going on in the water vapor. A bunch of low clouds here over the Atlantic once again. You can see all those low clouds there. A ton of low clouds. And indeed over the Gulf, even over Florida, low clouds galore. And low clouds are associated with cosmic rays, if you're wondering. As the atmosphere gets denser and denser, it is more likely for incoming protons and other radiation from space to run into something and cause Bremsstrahlung. Yeah, Bremsstrahlung. Can you say it? Bremsstrahlung. Or breaking radiation, usually emitted by electrons, creating a photon as they change energy states. A thing you would see in cyclotrons and synchrotrons. Anyway, once again, there's the water. And we're going to zoom in here on Texas. A possible future location for smAshomash.org. 'Cause everything's bigger in Texas. The barbecues are smokier down there. It's bigger in Texas. And you can see a bit of stagnation there, and that's what's causing those systems to stay in place long enough to deposit so much snow. And we've got bonus features, so stay tuned. We're going to show you the high-resolution intensitygram and the high-resolution colorized magnetogram as well. Something we do regularly here at the Smash News Network. Something else we do regularly here at the Smash News Network is that I vanish. So here's the colorized magnetogram. And frankly, we ain't got no sunspots. We ain't got none. That might be one by now. I thought I was seeing a dark spot open. Let's see if it happened once again. Did the sun oblige us? I think that's a sunspot, folks. This one might get named. It might get named. It looks a little on the dark side on the intensitygram. And let's show you our other HelioViewer movies. We've always got great ones. And we'll close things out with the 171 angstroms and zoom in. So there's 171. And we'll take a closer look at that active region in the same wavelength. Possibly our latest sunspot. We'll see if the umbra remains intact for 12 hours, which would be long enough for it to be there for the majority of a day, in which case it'll get a name. Also some filaments there, south of that active region. And we'll also show you 304 angstroms. Since there is filamentary behavior down there. Also, you can see a sprite up here in that wavelength. And we'll show you that active area in 304 as well. Thanks for tuning in. Enjoy the rest of your Sunday. Remember, stare at the sun. Use the proper instruments like our channel. Don't drink, and if you do, don't drive. And since it'll never be now again, Welcome to the Neo-Renaissance, and may that solar wind be at your back.